Let's take a look at some of the math operators now. Right? There's both binary, meaning they need 2 operands, and unary, they need only 1 operand. We've seen some of these before, right? Plus sign for addition, minus sign for subtraction, multiplication is the asterisk, division is the /. And then we'll see there's an operator called modulus that only works for integer data types, right? All of these associate from left to right. Meaning we'll do x plus y, x minus y, x times y, x divided by y, and then x modulus y. We'll see that modulus for integer data types gives us the remainder, right? It divides x by y and tells us how much is left after that division. Right. One thing you want to be aware of, the difference between integer and floating point division. Right? So if we've got an integer variable x, and this is for any integers in the integer family, right? X divided by 3, in this case when x is 10, 10 divided by 3 is 3 1/3. But because we have to store, or because x is an integer, we lose that 1/3, that fractional 1/3. It's dropped. So the result of x, or of 10 divided by 3 is actually 3. Right? Now, if you try to divide an integer by 0, you'll get a divide by 0 runtime exception, and your program will die. Right? That works for integers. Now, floating point division, right? X divided by 3. Well, floating point can represent that, or digits to the right of the decimal place. So you'll get 3.333 repeating. And then with floating point division, if you happen to divide a floating point number by 0, you'll actually get infinity, and your program will keep running. So it will crash for division, for integer division by 0, but it will keep running for floating point division. Now let's just take a look at the code blocks program. All right. I've got up and running here. All right, here x and y are integers, right? This is showing the results of each one of these operations then. Right? X is 5, y is 4. You can see the results of addition, subtraction, multiplication are shown here. Here's the integer division. So this is 5 divided by 4, right? That leaves a quotient of 1, and then because 4 can only go into 5 one time, it also leaves a remainder of 1. So x mod 1, we say x mod 1 gives us a remainder of 1. Right? 5 divided by 4 leaves a remainder of 1. And that's how that works for integers. Right. Let's just go ahead and change this data type. Sorry, I need to stop that running. Change this data type. Now let's just change these to floats. All right. You see we have then make that 4.0. Technically I should make these constants f to be floating point instead of double type. Right. I'm going to comment out the remainder operator because modulus doesn't work for float. Well, actually, let's leave it in and compile. So build, compile. Right. We get a compilation error down here. Error invalid operands to binary percent sign, so modulus have float and float. So that's illegal, right? We'll comment that out. Now, if we build and run, right? See, we get, oh, well, no, we don't get the same results because I had to do more than comment it out, right? On my system, I got all zeros here because I didn't change from D to F. Well, now let's build and run. Now that I've got the right conversion specifier. All right, so we get 9, 1, 20, and 1.25. All right, we get those 6 decimal places. I could have cleaned that up, right, by showing less decimal places. We get the 6 by default, but we can see here the difference between integer division and floating point. 5 divided by 4 gives us 1.25. So we don't lose that portion to the right of the decimal place. All right, now let's take a look at what happens if we have divide by 0. Now, let's leave these as floats right now. All right, and let's just go ahead and change this to x divided by, well, here. Let's set y equal to 0. And then let's put this line of code up top to illustrate that our program keeps running, right, or generating output. All right, we should get zeros for everything except for the infinity. Build and run. Okay. So this first one, x divided by y, when we did the division by 0, because y is 0, notice that the output I got here was INF, so it at least let me know that that's infinity. Right. Everything else, well, 5 plus 0 is 5, 5 minus 0 is 5, and 5 times 0 is 0. That's what floating point does. Now let's change this back to integer values, int. Right. Change these constants back. And change the, back to a lowercase d. All right. Let's see, if we compile, see, we don't get any warning because it's going to let us do that. And actually mine stopped working, but it pops it up on the other screen, so you can't see that. Here's what happened. So the console window came up, right? A little spinning wheel, Windows little spinning blue wheel came up, and eventually I got this message that expressions.exe has stopped working. Right, debug would pop up a lot of code on the call stack, and I'd have to open the debugger to actually see what was going on. I know where it failed right here, so I'm just going to close the program, right, and then end that. So you can see the difference then, that division by 0 in integer caused the program to terminate. All right. All right, so we talked about the modulus operator, right? It has lots of uses. All right, we'll see them as we go along. All right, that's an example of incorrectly using the modulus operator with float, which I've already shown you. Now the modulus operator, right, it works with both positive and negative numbers. Right. So if you have 16 mod 3, well, that'll divide 16 by 3, right? 3 goes into 16 5 times. 5 is the quotient, leaving a remainder of 1, because 16 minus 15, which is 3 times 5, gives us 1. Right. Now, 16, if we divide that by -3, well, if we multiply -3 by -5, we get positive 15, leaving us a remainder of 1. -16 divided by 3, we have to multiply that by -5 to get -15, leaving a remainder of 1. And then finally, -16 divided by -3, well, if we multiply this by 5, it still leaves us -1. Right, so 16 is the dividend in each of these cases. These are the divisors on the right. These are the remainder. So it works for positive and negative numbers as well, right? But for integer data types only. Now you can do mixed type arithmetic as well, but once again, we avoid something like this. We'll see that C promotes types. So if we define x as an int, and we have an expression that's x plus 9.2, well, 9.2 is a floating point type. This constant is of type double. So what this does is it will evaluate or promote x as a double just for the purposes of this expression. It does not change what's in x's memory, right? It has no side effect of changing memory, but this is then, we'll say something like 10 point, well, sorry, if you had 10 stored in x, my bad, but if you have it stored in x, if it were 10, this would be the same as 10.0 plus 9.2, giving us 19.2, but depending on what we stored it in, right, as to whether we keep the decimal point or not. We try not to mix math, but when you do, the idea is that the smaller types, so an int we consider to be smaller, right? Anything that has this floating point we consider to be larger because it can hold information to the right of the decimal point, so it will promote it to that type. Right? If both operators in this case are integers, so if x is an int, we declared it up here, 4 is an int, the resulting type of this expression will be an int. These are important to know, especially in light of some compiler warnings you may get, right? Knowing what these data types are will help you determine what the error or the warnings are telling you at some point. Right. For the most part, we try not to mix the math. Right. And then order of precedence. Well, division and multiplication are the same level of precedence. They're higher than addition and subtraction. Right? And then, of course, our assignment operation is the lowest. Well, let's look at this expression. Because multiplication is higher than addition, it will actually then multiply 3 times 4, shown here, and then add 2. So we get a result of 14. And as I said in a previous video, right, when operators are of the same precedence, they evaluate from left to right. So we can see in this that we have a multiplication and a division. Those are of the same level of precedence, and they're higher than the plus and the minus. Since these are of the same level, these will work from left to right, meaning we'll have the 3 times 4 evaluated first, which will give us 12, divided by 6 will give us 2. And then since the plus and the minus are the same, the leftmost will be evaluated. So this will say 2 plus the 2 that's evaluated to 4. We'll subtract 5 from that and get a -1. So it works just like the math that we know. Right? You can always use parentheses to change precedence, right? Just like we can in math. When we put parentheses around an operation, it forces it to happen first. In this operation, parentheses around the 2 plus 3 will cause the addition to happen first, and then the multiplication will happen. So this is not the assignment operator here. I'm really using this as a mathematical equality. So 5 times 4 is 20. In this case, I have 2 plus 3. This will be evaluated. It'll give me 5. This is in parentheses, so we'll get 1 here. 5 times, well, this is in parentheses, 4 divided by 1 still gives us 4. So we'll get 20 here as well. Just a more complex expression, different order of operations. Right. So order of precedence, the highest is parentheses. The next highest is the multiplication and division. Then after that comes the addition and subtraction. And modulus is in between those two. Unary arithmetic operators, right? You can put a plus sign in front of a constant or any variable. Well, it just makes it positive by default, right? If we don't put the plus sign there, it's whatever. If it's a constant, it's already positive. If it's a variable, it's whatever's stored in the variable's memory. If you want to negate what's stored in memory, right, you put a negative sign in front of it, or you can negate a constant. Same way we do in math. These work just the same in C. Right. So our unary operators go here, right? So we have parentheses highest, then unary operators, then our binary operators in this order, right? That's the end of arithmetic operators. And let's bring up compound assignment operators while we're here. There are several. These are just shortened expressions. You'll get used to seeing them. They look a little bit strange at first. Plus equal, right? The plus equal expression will change. So whatever's on the left-hand side of this compound operator here will change its memory. So x plus equal y is the same as saying x, assign to x the value of x plus y. X minus equal y, well, what it does is it will perform x minus y and then assign that back to x. X times equal y, well, will perform x times y and assign it back to x. So it always changes the memory location of the variable here on the left. Right? Divide equal, these are just shorthand ways of writing this. Right? Write either technique that makes more sense to you. Right? Most people don't use these in the beginning because they're not intuitive. Right? We won't worry about these. These are bitwise operators that we haven't studied yet. We'll come back at a later time and study these compound assignment statements. All right. And there are just some examples in there of how that works. We'll use those a little bit in class. Don't really feel like you need to know them right now. Right. Next lecture will be about increment and decrement operators.